Okay, so now we're going to be starting our integration video series. In this video series for Pure 1, the integration techniques are very simple and very easy, and they're going to get a bit more difficult when we go to Pure 2. Okay, so we're just going to look at the basics for now. So first things first, when we differentiate y, right, we get dy by dx. That's what we do when we differentiate. Integrate is actually the opposite, right? So what we're happening is we start off with dy by dx and we're trying to get to y. Okay, so we're trying to integrate to y. And you'll normally see something like this. So this is the integral sign, and you'll see a function in here. I'll write it as f of x. And then you'll see dx like this. This just means that we have to integrate the function with respect to x. It's a very basic thing. So if we have a function x to the n, like this, and so if we want to integrate this, x to the n, then what happens is you have to add 1 to the power, so it now becomes n plus 1, and then we divide it by n plus 1. Okay, so it's different to differentiation. Differentiation was we move the power down, times it, and then minus 1 to the power, right? In this case, we add 1 to the power first, and then we divide the power. And then we can't forget something called a constant plus c. Okay, so this is a constant c, which is, you always need to add this c part now, okay? So if you forget the c part, sometimes you will lose marks. This is because this is known as an indefinite integral, because we don't know the c value. Later on in a later video, we'll go about finding the c value, but for now we don't know what the c value is, so we just add the plus c, and so it's called an indefinite integral. Right, so if I was to say, how do we integrate x squared dx? So as I said, you add 1 to this power, so it becomes power 3, so x to the power 3, and then we divide it by that power, so over 3 plus c, like this. Simple as that. Let's say maybe integrating 1 over 2 x to the power 4. This 1 over 2, we just leave it as b, so this is going to be 1 over 2 now. And then you integrate x to the power 4, so plus 1 is over 5 like this, plus c, which will simplify to x to the power 5 over 10 plus c. Don't forget this plus c. Okay? Maybe you could try integrating 2 over x squared dx. So like the differentiation, you want to rewrite this in like a indice form. So I'm going to rewrite this as integrating 2 times x to the power minus 2 dx. And then it's easier to integrate, right? Because you want add 1 to this power. So leaving the 2, it'll be x to the power minus 1 over minus 1 plus c, which will simplify to minus 2x to the power minus 1 plus c. We can even integrate just numbers like this, right? So it's, for example, 3 dx, okay? So as you can see, there's no actual x terms here. But if I was to rewrite this as 3x to the power 0, we know anything raised to the power 0 is automatically 1, right? So we can still write it in this form. Then I do the same thing. So you add 1 to the power, so it'd be 3x to the power 1 over 1 plus c, so it's just 3x like this. In fact, integrating any number is just automatically, you just have to put an x behind it, okay? So you don't have to show the steps, I'm just showing you how we get to that step, but you don't need to show these steps. Let's try something more difficult. So let's say we have 2x plus 1 times x minus 1 dx. So like differentiation, we want to expand the brackets first and then integrate each term separately. So expanding the brackets, we'll get 2x squared plus x minus 2x minus 1. I can simplify this a bit further before integrating 2x squared minus x minus 1. And now I'm going to integrate, okay? So integrating each term separately. So the first time we 2x cubed over 3 minus x squared over 2, and minus 1 is just minus x, you just times the number by x plus c, like this. Does this rule stand? So let's say we have like x minus 1 cubed, no, let's get x minus 1 squared over root x. So once again, you just want to expand and simplify, separate each term. So we'll have x squared minus 2x plus 1 over the square root of x, which is x to the power half, which I'm going to divide each time. So we're going to have x to the power 3 over 2 minus 2x to the power half plus x to the power minus a half dx. And now I can integrate each term separately. So this would be, adding 1 to 3 over 2 is going to give you 5 over 2, and you divide it by 5 over 2, minus 2x 1 over 2 plus 1 is 3 over 2, divided by 3 over 2, plus x minus a half plus 1 is going to be a half, so divided by a half as well, plus c. Which I can simplify a bit further, so this would be 2x to the power 5 over 2 over 5, minus 4x to the power 3 over 2 over 3, plus 2x to the power of a half plus c. So as long as you separate each term and write it in indices form, then you just have to integrate each one separately, and then you can answer more difficult questions like this one here. And so this is just a basic way of integrating x terms. You look at more difficult trig terms to integrate in later videos, as I said in Pure 2, but for now this is all we really need to know.